It says, given this, show all the work used to determine the critical points. So the critical points are basically where you have usually x-intercepts, or where it's undefined. It's typically what they mean. Or vertex. In this case, they want the vertex, the y-intercepts, x-intercept. Use an appropriate scale. Transform the quadratic from standard to vertex by completing the square. So let's do that first. So completing the square, remember what you do is you factor out a -4 from the x squared. So this would be -4x minus 13. So notice I only factored it out of these first two. I factored a -4 out. Don't forget you'd have a -4 in here too now. Now I'm going to take half of this number, half of that number, and square it and put it here. So half of -4 is -2 squared is +4. But what I really did, if you think about it, I really introduced -4 times 4 into this equation. So I've really introduced -16. So I have to balance that out by adding a 16 on the outside. Make sense? So this would equal -4 times x minus 2 squared. That's why it's called completing the square. That's a perfect square trinomial. Plus 3. So there's my equation. Y equals that. And now I can say the critical points. Well, first of all, one of my critical points I could see up there was 13. So my y-intercept was 13. Y-intercept was 0, 13. That's one of them. Now, my vertex, I can see my vertex easily from this vertex form here. It's +2, +3, 2, 3. And now my x-intercepts are also easier to find from this form, because I can just solve this. I can plug 0 in for y and solve that for x. So it's -3. I subtracted 3. Now I divide by -4. So that's really +3/4, right? And then I take the square root of that, the plus or minus square root of that, and then I add 2 to it. So my intercepts are 2. I'm going to move this around a little bit. 2 plus or minus the square root of 3 over 2. Right, if you understand what I did there.
Yeah.
Comma 0. Those are my x and y intercepts. So they said use an appropriate scale. Well, 13 is my my y-intercept. But to be honest with you, I kind of want to keep this just as 1. So let's still call this 5 and 5. And it's no big deal if we go up here a little bit for the 13, right? That's what I would do. 2, 3 is my vertex. 2, 3 is my vertex right there. My x-intercepts are, whoops, something's not right with my vertex there. Something's wrong. Oh, -13. I'm like, how could that be my vertex and I have 2 x-intercepts? -13 is my y-intercept, not +13. So it's down here. That makes more sense.
Yeah.
Right? Because I'm going to be, remember what my vertex, that means that I have my axis of symmetry is right there. And if I go square root of 3, 2 to the right, square root of 3, 2 is like, square root of 3 is like between 1 and 2. So this is like adding, what's square root of 3 over 2 roughly? So that's less than 1. So I'm going less than 1 to the right. Let me make this red so it's easier to see. So I'm going less than 1 to the right and less than 1 to the left of 2, right? And there was 2, and so that's what's going to happen. So it's a really steep graph. It's doing that, and it's doing that, roughly. Okay.
Makes sense.
And now it says fill out the blanks below and graph the quadratic. Oh, I guess I've already filled that out. So the axis of symmetry is x equals 2.
2, yeah.
X equals 2. The intercept is 0, -13. That was the y-intercept. The x-intercepts are 2 plus √3 over 2, 0, and 2 minus √3 over 2, 0. And the vertex is 2, 3.